All right, here we are, Pre-Calculus 30. This is Chapter 6, review question number 9. Okay, and we're talking about trigonometric identities. We're talking about evaluating cosine, sine, tangent sort of thing using our identities. And so here you see here in question number 9, the first part, and I've got the question all done here. I'll just walk you through it, okay? This will be a quick video. But what we're looking for here, as you can tell, is we're looking for an evaluation. So what is the actual number answer for this quantity right here? It's cos of A. Now we don't know what A is, okay? We know that A is in the second quadrant. That's between pi over 2, which is right here, and pi, which is right here. So we know that it's in the second quadrant. And we're also given an angle of pi over 4. So a second quadrant angle minus pi over 4, which is obviously a first quadrant angle. Now, the thing is we don't need to find this angle first. What we need to do is we need to use our sum and difference identities. So here's cos of A minus B, see that? A minus B. And we can rewrite this difference in terms of the multiplication of the cosine value of A and the cosine value of B and the sine value of A and sine value of B. So we don't actually need to know what A and B are. We just need to use the cosine and sine values. So we're given cos of A. It's right here, negative 5 over 13. Now what does that actually mean? Well, it means from the origin we go negative 5 or 5 units in the left direction, and then the 13, if you remember from this memory mnemonic right here, Sir Coxertix, right? The CXR, that means cosine is x divided by r. So we have a 5 here, and we have a 13 is the distance from what would be this point to the origin, right? That's the hypotenuse of this little right triangle. So that's what we're given, 5 and 3. And I can find out what y is using Pythagoras' theorem down here. And so that's what I've done. I've 5 squared, y squared, and so on. And I found out that y is 12. Now, why does that help us? Because now what we have is we have the ability to determine what sine of A is, right here, you see? So sine is y over r, or 12 over 13. Okay, so I've got cos A that's given, I've got sine A now that I've figured out, and of course sine of pi over 4 and cos of pi over 4 are both root 2 over 2. Okay, so once again, I do not need to find out what A is. That's the big thing. A lot of students think, oh, I gotta do like cos the negative 1 of negative 5 over 13 and get, no, you don't, because it's not going to be an exact value. You want to use exact values here to evaluate the following. So we'll just use the cos and sine values. We use these four, and now we just look at this identity and we just plug them in here. And so cos of A minus pi over 4 is actually the same as multiplying this cos of A times cos of B plus sine of A times sine of B. And then when that's all said and done, you should get an answer like this, 7 root 2 over 26 as an exact answer. Okay? Now, if you had 7 over 13 root 2, that's okay. Ideally, we don't have radicals in the denominator. Technically, it's not simplified. So this would be your simplified version, 7 root 2 over 26. And that's question number 9 on your Chapter 6 review, Pre-Calculus 30. See ya.